So what I'm now going to do inside of this second part of the intuitive definition of limits is to talk about this idea of a one-sided limit, right? When we talked about limits before, I actually showed that you could come from either side, right, in terms of the x values, right? Either side of the x values in order for us to actually get the limit, right? So like the graph approached our limit of f of x as we approached from either the positive side or the negative side of 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 our values, okay? We actually have some definitions for this because they end up becoming really important. So the limit as x approaches a from the positive side, and you see this plus sign of f of x, right, is called the right-handed limit, all right? So it's coming from the positive side, right? So we're going to come in, so like your mirror imaging. So we'll come in from the right side, right, and approach f of x from that side. That's a right-handed limit. Or the limit as x approaches from the positive side. The limit as x approaches a negative, right? You'll see that that has a minus in the subscript, okay? It's called the left-handed limit. The left-handed limit, and so it's coming in from the negative side, okay? Or as x approaches from the negative side. So we have these two. You'll notice the notation, right? Be very careful about that notation, x plus, or a plus and a minus, all right? Because that differentiates between when it's coming from two different sides. So sometimes we have a function that does not have a limit at a point A, but it will have a right hand and a left-handed limit. Okay, so that's why these things are important, is because now we're getting into the nuances of mathematics, and sometimes you have something that like it doesn't exactly have exactly the definition that you're looking for, but it has part of it, right? Okay, it has part of it. Like in this case, it doesn't have a limit per se because coming from the left-hand side and the right-hand side, it might be different, but it does have a right-handed limit and it does have a left-handed limit. Okay, so let's take a look at an example. Let's consider the function f of x equals, and it's got this box, x, which is called the greatest integer function. And it takes the value of x and then sets f as x if x is an integer, and the next largest integer if x is not an integer. So what that means is, like, for example, f of negative 2 is just negative 2 because negative 2 is an integer, right? F of 2.72 is going to be 3 because that's the next greatest integer, right? Okay, that's hence the greatest integer function. And then f of negative 2.375 is going to be negative 2 because negative 2 is the integer that's larger than negative 2.375. It's the next one up, right? You got to be careful with this function. It's just the negatives. The negatives matter. They're different. Okay? So when I look at the graph, this is what the graph looks like. Okay? What we see is that we've got these open dots. So like say for example, here at negative 4, excuse me, this is 1, 2, 3, 4, okay? At negative 4, going from negative 4 to 3, we're actually at 3, but we have an open dot, right? Okay, because f of negative 4, in fact, equals negative 4, right? But anything just slightly more than that is going to end up being negative 3, because that's the next greatest integer, okay? If we're down here, if we go anywhere between negative 1 and 0, it's going to be 0, right? So that's in this area right there. But f of negative 1 is negative 1. All right. So you just want to kind of like sit there and think about that for just a second. Make sure you understand what the function is actually saying, right? It's the next greatest integer. So now let's answer these questions. What is the limit as x approaches 0 plus of f of x? All right. Well, if I'm looking at 0 plus, right, okay, what I see here is that actually as f approaches 0 plus, okay, from the positive side, right, that's actually equal to 1, right? Because get closer and closer and closer to 0 from the positive end, okay, we're actually, all of our f values there are equal to 1. So as x gets closer to 0 from the right, f of x equals 1. So that limit, right-hand limit, is equal to 1. On the other hand, if you go from the negative side we just showed, right, okay, is going to end up equaling 0. So as x to 0 from the left side, f of x is going to equal 0. So now we have a problem. From the left-hand side and the right-hand side, right, we get two different numbers, right? Okay, so as we approach from the left-hand side, okay, as we get closer from the left-hand side, it's 0. As we get closer and closer from the right-hand side, it's 1. Ooh, that's a problem. What that means is the limit does not exist. So that limit does not exist. But it does have a right-hand limit and it does have a left-hand limit, okay? Because we do, in fact, see it approaching, right? As when we're coming from the left-hand side, right, okay, it's approaching 0. And when we're coming from the right-hand side, it's going to be approaching 1. There you go. There's an example. And this gives us a really important theorem. The limit as x approaches a of f of x equals L if and only if, and this is really important. This means, right, that if we have a limit, this is always true. The limit of f as x approaches a positive equals L, right, equals the limit as x approaches a negative of f, right? So basically we're saying the limits, the right and left-handed limits have to agree. So the right and left-handed limits must agree. And if they don't agree, right, if this is not true, that also means that we don't have the limit. So if we have the limit, the left and right-hand side of the limits agree. And if we have the right and left-handed limits agreeing, then we have the limit. I know it sounds like it's the same thing. It's not exactly when we talk about things from a proof perspective. And this limit section, a lot about proof. Okay? So really important for us to have a limit, okay? For us to have a limit, the two left-handed limit and the right-handed limit have to be the same. All right, so this finishes up our mini lecture on right and left-handed limits.